module 5 today and then go to module 4 so that you know what you're going to do during the weekend to prepare yourself for the exam next week. Okay. Now, what I'm going to do is I'm going to use the material that are available in your module because I'm trying to see why your performance is not really good during your exam one when you have all the materials that you need to prepare yourself for the exam. Okay. So, module 5. So we're done with the first law, second law of thermodynamics, and some other stuff in module 5. So I want you to look at some of the materials that we have here. I don't know if you're using this link. So if you click this one, so makikita nyo, may mga added information dito. You see that one? Kinetic energy, potential energy, internal energy. Okay. And in addition to this is the same material that I have in my recorded lecture. If you, oh no, nasa na siya? Wala. Okay. And then some problems that you have here. Yung Hess law na meron tayo last time. There's some example that you have here. You can go over the practice. Okay. So what we're going to do right now is to end module 4. Wala akong waitlist sa Zoom. Usually, I allow everyone to enter the Zoom right away. Wala akong pictures na sa waitlist. Kasi annoying siya yung okay. So what we're going to talk about today is the so-called phase changes. Okay. And you will be introduced to this concept of heat of fusion, heat of sublimation, heat of vaporization. And as I promised, I'm going to use the material that we have here in the syllabus. Do you know that you have this material?
Yes.
Ginamit nyo ba yan?
Yes po.
Hindi na-charge yung pad ko eh. Naubos before sa klase. Okay? So if you're going to look at the phase changes, so this is a physical change wherein only the states of the material changes, but the chemical composition is still what we call the same. Okay? And if we're going to look at the 6 common changes that we have here, so this is what we have. Melting, vaporization, sublimation, solid to gas, okay? Solid to liquid, that's melting. Solid to liquid to gas, that's vaporization. The reverse of that is here. Condensation, the reverse of vaporization, so gas to liquid. Deposition, gas to solid form without passing the liquid. And then freezing from full, now what we call liquid to solid. Okay. Now, if you're going to look at this one, any heat associated to convert a material from, let's say, solid to liquid, liquid to gas, that is the heat of a certain process. So when we're talking about heat of fusion, that is the heat that you need to convert from solid to liquid. Now, it can be joules over mole or joules over gram. Okay? And then you can also put heat of vaporization. So that's the amount of heat for your liquid component to become gas. Now, if you don't pass through from solid go directly to gas, you have the liquid, you have the heat of sublimation. Now, anong relationship ngayon? Just going to. Anong relationship ng mga to? Try to analyze. May kukunin na ako. So, anong relationship nila? Anyone? You apply Hess law here. So heat of fusion is what? Water from solid going to water to liquid. And this is water from liquid going to. So you cancel this. So when you have it, so ano yung Hess law? Heat of sublimation is just equals to what? Anyone? Class? Hello? Ano yung relationship no? Tatlo. So heat of sublimation is just the sum of heat of vaporization and heat of fusion. Okay? So this is just an application of your Hess law. Now, if you're going to look at the other heat, so meron tayong tinatawag na heat of solidification, the reverse of fusion, heat of deposition, the reverse of sublimation, and then heat of condensation, which is the reverse of vaporization. Meron din tayong tinatawag na supercooled liquid, superheated liquid. Okay? So if we're going to look at the thing here, so yung mga heat of condensation, solidification, ito mga yun, yung reverse lang. Dalawa. And usually, if you're going to look at this one here, ito yung heat of fusion, ito yung heat of vaporization. Now, the question is, bakit laging malaki yung heat of vaporization kaysa sa heat of fusion? Anyone? Why is it that this is always bigger than this? Anyone?
Tama po ba yung fusion po yung freezing?
Ha?
Yung fusion po ba yung freezing? Tama po.
Yung fusion ay yung reverse ng freezing. That's melting. Ang fusion ay conversion from solid to liquid. Ito. This one. Okay? So why? You not answering only shows na hindi niyo binabasa yung material na to. Nandun yung tanong, nandun yung sagot, oh. It has something to do with the IMFA that is involved. From solid to liquid, okay, you still have the IMFA. What you break is that what hold the solid together. When you overcome it, there's still IMFA in the liquid phase. Now, unlike from liquid to gas phase, wala nang IMFA sa gas phase. So that means you have to break whatever that hold the atoms together. And you're going to need a much higher energy for that. Yun yung explanation. Okay? And the summary of that, less energy is needed to allow molecules to move past each other, yung nangyayari sa solid to liquid, compared to separate them totally, yung nangyayari from liquid to gas. Okay? So, dito rin sinasagot yung tanong ko kanina. So, nandyan lang lahat yung sagot sa tanong. Okay? Now, if you're going to look at the value of the heat of fusion and heat of vaporization, this is an evidence that you need more energy dito sa vaporization kaysa dito sa fusion. Look at the value. They never tell a lie. Okay? It's always a truth that you need more energy to separate a liquid into a gas compared to melting a solid into a liquid. Okay? Are we clear on that?
Yes, please.
Now, the next thing that we're going to talk is has something to do with what we call the thermal curve. So when we have a thermal curve, okay, this is a plot wherein you are adding or removing an energy with time and looking at the temperature changes with respect to the phases that it changes during the process. So if it's heating curve, you're adding heat to the system. If it's a cooling curve, you're removing heat. So if it's a heating curve, you're adding heat, so your temperature will go up. If it's a cooling curve, your temperature will go down. Okay? So, meron kayong ano dito, parang activity. And to answer that question, you need to open, okay, yung nakalagay doon sa phase changes na dito, is still part of this one. So if you're going to look at this, this is a heating curve. So you have your time, and then energy being inputted or added, and the given temperature. So you have here some points that's happening. So from here, A to B, what do you think happened to the temperature? To answer the question there. A to B, is the temperature constant? You can always chat or answer the question. Is the temperature constant from A to B?
No,
Yes or
No,
no?
po, sir.
No, because it's going up. Okay. Is there a phase change? Yes or no?
No po.
No,
No, because all of them are what? From A to B, it is
ice.
solid. Okay. So the state present that you have, there's solid, there's temperature change, but there is no phase change. Now we go with the second one. B to C. What happened?
Sustained temperature.
Okay, is there a temperature change? B to C?
None.
no.
None. It's
No.
all 0 degrees Celsius, and you could say this is your melting point. Okay. Now, how about the phase changes? Is there a phase change? The answer is
Yes.
yes, because this is now a mixture of what? Solid and liquid. So at the beginning, it's all solid and starts to melt into liquid. And by the end, it's all liquid. And then it starts to go up again. And from C to D, is there a temperature change? C to D?
Yes.
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 Is there a phase change?
None.
No, because all of them are Ano yung phase niya dito?
Liquid.
Liquid.
And then here you could see this is your boiling point. Now, this is another thing why delta H of vaporization is higher than delta fusion. Look at the wide range of time. So anong ibig sabihin yan? You spent more time because you're applying more energy compared to this one. So is there a temperature change here?
No.
None.
No. Is there a phase change?
Yes.
Yes.
Yes. So here your liquid start to become gas. And then from E to F, it is all gas. So kaya nyo sagutin ang tanong pag meron kayong plot na ganon at sasabihin what is our phase to bases present. Let's say from B to C, or you may ask the question true or false from C to D temperature increases. Kaya nyo tanong? Kaya nyo sagutin?
Yes.
Yes po.
Yung iba? Siguro or sigurado? Pero yung unang section ay siguro po. Ayoko na siguro, dapat sigurado. Okay? Now, you have here what we call yung tinatawag na super cool or superheated. I think it's here. So usually yung mga superheated liquid, it's applied here. So what happened to the superheated liquid? So kapag pinat ko yung phase change, so let's say ganun na, no? So yung superheated liquid, usually mataas na siya, yung temp, tapos liquid pa rin siya when it should start to form a gas. So yun yung super cooled. Now yung super heated. So super cooled, usually dapat ano na siya, magso-solid na pero liquid pa rin siya. Tapos naging what we call solid. So yan yung super cooled, ito yung super heated. Okay? Now, in addition to this one, we can also use or determine the amount of energy that we need. So if I ask you the question, will you use the same amount of energy if you want to heat 1 gram of ice compared to 100 grams of ice? If you want to melt 1 grams of ice, is it going to be the same energy as you need to melt 100 grams of ice? Yes or no? Huh?
No.
No. Because as I told you, enthalpy, the energy that is associated for reaction like this, is an extensive property. The more material that you have, the more energy that you have. Now, if we want to determine the amount of energy that we need, okay, we use some formula here. So we are introduced to this concept of what we call Q times M, specific heat, and change in temperature. So in some other books, it could be Q equals to MS delta T. So this is true if you transition from one temperature to another temperature without phase change. Now, if it involves phase change, so it is Q equals to N over the heat of whatever process that you have. Heat of fusion, okay, or heat of vaporization. Now, you only have N here. What is N? Anyone? Ano yung definition natin ng small n? Mole.
Product minus moles of reactant.
So if you have n, make sure that your heat of fusion is also in what? Joules per mole. But if you have grams, make sure that your heat of fusion is in joules per gram. So you have to be very careful with the units there. Okay? Now, whenever, balik ako doon sa notes natin, we are asked to what we could look at the amount of energy or heat needed. Itong tinatawag nating specific heat. Okay? It's a constant value that is given to a particular substance. So, ibig sabihin, iba yung specific heat ng one substance from another substance. Okay? And ang definition ng specific heat is the amount of heat required to raise the temperature of 1 gram of any substance by 1 degree Celsius without phase change. Okay? So, paano natin iaano to? So, merong ano dito example. Aminin nyo, have you seen these materials in other modules? Ha? Yung totoo. Nakita nyo ba ibang modules na may ganitong material? So most likely, hindi.
Yung solved exercises po ba?
Ha?
Yung may questions po ba yan?
Hindi.
Yung may word problems?
Yung iba, yep. So if you're going to look at the link here, okay, please utilize them. It will help you to prepare yourself to understand the material. Okay? So if you're going to have a problem like similar to this one, kita nyo ba lahat? Yan nandun si Oble.
Yes. So,
So here, you have a situation wherein you have 180 grams of water. You want to heat it from 10 degrees Celsius to 105 degrees Celsius. And you're giving the specific heat of water and steam are 4.18 joules per grams per centigrade and 2.03 joules per grams centigrade respectively, and heat of vaporization of water is 2.26 times 10 to the 3. Now, there are 3 conditions here. Okay, why? From 10 to 105 degrees Celsius, it passed through what? The boiling point of the water. So that means you have to determine the heat that you need to raise the temperature of this amount of water from 10 to 100 degrees Celsius first. Ito yun. You follow?
yes.
At ano yung magsosolve dyan? Usually yung mass times the specific heat of water. So this is water, which is 4.18, and times 100 minus 10. So that's the first source of heat. Now the second source of heat will be, once you reach the boiling point, you're going to multiply the amount that you have there with the given delta H of vaporization. So 180 times 2.26 times 10 to the 3. And then once it melts, or not melts, boils, you also need to determine how much energy you need to raise the temperature from 100 to 105. And if you're going to follow the answer here, so you have it here. So the first one, 180, 4.18 times 90. And then the second one, 180 times the specific heat. Oh no, heat of vaporization. And then the last one, 180, but look, 2.03, not 4.18, because the given specific heat of steam there is this value. And then once you get it, you're going to add everything. Analyze. And there's another example that we have here, and then we're going to answer the question that we have here in the module. At least I'm going to show you how to do it. And I leave it up to you how to get the 8.2 times 10 to the 4. So kung may problem na ganun, kaya?
Yes.
Class? Kakayanin. So the second situation that we have here, starting point -12, and you want it to go to 20 degrees Celsius. So it will pass through what? It will pass through the, anong point?
Melting.
The melting point. So the first source of heat here, the heat that you need to raise the temperature of 50 grams of ice. So there's a specific heat of ice there. Okay. From -12 to 0. Right? And then once you reach the melting point, the amount of heat that you need to melt the ice, so 50 grams times 334 joules per grams. And then once it becomes water now, the amount of energy that you need to raise the temperature from 0 to 20. So 50 grams times the specific heat of water, which is 4.18 times 20 minus 0. And if you're going to put the number, this is what you have. First step, the second step, and then the third step. Analyze. I hope everyone is listening. Baka mamaya naka-log in lang tapos hindi nakikinig. Tapos pagdating ng exam, hindi po sa amin diniscuss ito. All the while, the material is there. So let's try to do the situation that we have here. Calculate the amount of heat needed to convert 120 grams of ice at -7 degrees Celsius to liquid water at 80 degrees Celsius. Assume that the amount is constant all throughout. So ano yung first point natin? So we have, anyone? So we have 120 grams. So from -7 to ano? 0. So we put the Q1, 120 grams times the specific heat. So we can use the one that we have earlier. So if we follow the given here, so this is ice. So specific heat of ice is 2.09. Nakakapalo? And then you multiply it with 0 minus -7, which is just 7 degrees Celsius. So cancel, cancel. So you have here in joules. All right. The next one. From here, that solid, it will go to still 0 degrees Celsius, 120 grams, but liquid. So you have Q2 is just what? 120 grams times. So if you're going to look again at the given, ala, nasara ko ata. Alam, nasara ko yung ano. Nasara ko yung web page. Medyo choppy yung teka lang ha. Ano ba yan? Papalagin ako ulit. I just want to show to you the value. Para makita nyo or masundan nyo. Google notification. So 334. Okay, so just to show you. Kung nasaan yun. Saan yun? So ito pala hindi ko na ipakita sa inyo. Yung melting, freezing, boiling, evaporation, condensation, sublimation, and deposition. I think I gave it last meeting. Yeah. So here, so you see there, 334 joules. Now, it's already in grams. Now, paano kapag ang given ay ganito? Anong gagawin nyo? Class. Kapag joules per mole. What will you do?
Molecular weight po.
Huh? You have to convert
Molecular weight.
this one into moles. So you have to multiply it with 1 moles over 18 grams, or you have the 120 grams divided by 18 grams per 1 mole. Okay, so you have to be very careful. Okay, you're going to convert this to the moles, because usually the heat of fusion, heat of vaporization is joules per mole. It just happened that they gave it in grams here. So that's Q2. Now Q3, from 120 grams of 0 degrees Celsius is now going to go to, ano yung nakalagay sa ano natin? Ano yung final temp? 80 degrees Celsius. So it's just similar to Q1, but you have to use the corresponding what? Specific heat of your water, which is I think 4.18, right? Tapos 80 minus 0. And when you get the Q3 here at Q1, Q2, Q3, and your final answer should be the one that you have here in the guide. Kaya? Kaya, class?
Yes po.
So question. May tanong.
Excuse me po, sir.
Ha?
Excuse me po. Yung sa 18 grams po ba, yung molecular weight po ba yun ng water po?
Yeah, but you don't use it here. Kasi joules, ano,
So
10
kung
grams na eh.
yung okay po, sir.
You only use it if the one that is given is joules per moles, but it's already joules per grams. So cancel out lang yun, may iwan yung joules.
Okay po, sir.
Okay? So tanong, before we go to another topic here, the phase diagram. Ayan, when you click it, most likely si libre text ang lalabas. Okay? So, when you look at the phase diagram, this is just a graphical representation of the different phases at a particular temperature and pressure. Okay? So if you have a phase diagram, you plot temperature at the x-axis and pressure at the y-axis, similar to this one. And usually it will tell you what is the phase. That's why it's called phase diagram. So just to make it sure here, a phase diagram usually looks like this. You have temperature, you have pressure, and then you have what? So this one is the solid, this one is the liquid, this one is the gas. And then you have the so-called curve. If you're going to look at the lecture that we have, the notes that we have. So meron tayong triple point, critical point, fusion curve, vaporization curve, and sublimation curve. So if we're going to look at based on my drawing, ito yung fusion curve because it's between solid and liquid. Ito yung sublimation curve because it's between solid and gas. At ito yung tinatawag na vaporization curve between liquid and gas. Now this one is what you call what? Solid, liquid, gas existing at the same time.
Triple point.
So yun yung tinatawag na triple point. And then we also have one wherein at such state, you cannot distinguish if it is a gas or a liquid, and you call it the critical point. So at critical point, you have now what we call a supercritical fluid, which you cannot distinguish if it's a gas or a liquid form. Okay? So if you're going to look at the definition that you have there, it's there. The point on the phase diagram in which the three states of matter exist or coexist. The critical point, the point on the phase diagram in which the substance is indistinguishable between liquid and gaseous state, like this one here. So if you have a critical point, there's a corresponding critical temperature and a critical pressure. Okay? So what are the typical questions that you will have here? So I can bombard you here with a lot of questions. So for instance, dito sa drawing ko, I can ask you what happened in arrow A, what happened in arrow B, And what happened in arrow C? What's the process that you have in arrow A? Anyone?
Mel.
What is the process of that arrow? Anyone? What is A? What is happening in A? Transition from what?
Solid to liquid.
Solid to liquid.
So it is what? Anong
Melting.
process yun?
Melting process.
Melting. Okay? Now sa B, ano nangyayari sa B? It's from what? From gas to solid. And this is
Deposition.
deposition. And then sa C, you may ask, what are the phases, okay, happening in C, or from what phase C came from and going to? So it is what? From not solid, but gas to liquid. So this is,
Vaporization.
so these are the type of questions that you will be asked, and you should be ready to answer them. Right? Kaya ba? Maybe the thing that we can do is look at the unique example that was given there in the material. Pwede kang ganito like that. I think I have some worksheet that we can work. Ito, para at least magandang tingnan. Here. So maybe you put A, B, C, and you are asked what are the phase in A, B, C, what does T stands for, what is the C point here? Or you might ask transition, where you have a constant pressure. So what is the state of A? What's the phase of A? 1 here. Anyone? Anong state ng
Solid.
1? Solid. Nung 2? What are or what is are the state or states of 2? Ano?
Solid, liquid,
Solid pa rin.
Solid and
liquid.
liquid. That is what curve? Anong curve yan?
Melting.
That is the
Fusion.
fusion curve. Tika lang ha. Now, number 3. Ano yung state sa number 3?
Liquid.
Liquid po.
It's liquid. Number 4?
Liquid gas.
Liquid gas.
So, this is a liquid. Whenever you see a line, so that means the states or phases where it lies coexist. Whenever you see a line, so this is what? Solid liquid. So solid liquid na nasa line na yan. This one, liquid gas. So liquid gas yung nasa line na yan. Here, this is what? Solid and
Solid
gas.
gas.
So solid and gas ang naka-line na yan. So you should be able to answer a question like this. Okay? So number 5, what do you have there?
Gas.
5 is gas.
Gas po.
And then here, 6 is,
Solid.
Solid.
Solid po.
7 is
Solid and
Solid
gas.
gas.
solid and gas. And then 8 is
Gas.
Gas.
gas. And you may ask, so If arrow represent a process, what do you call that process? The arrow here.
Sublimation.
Sublimation. So kaya nyo sagutin yung tanong na ganon.
Yes po.
So pwede rin ganito. So what does number 9 represent here? State. Sagutin nyo na yung mga tanong na ganyan, no?
Some.
Solid.
Number 10,
Triple point.
Salt.
12 point.
Solid
So
liquid gas.
solid, liquid, and gas. And this one,
Gas.
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 Okay? So, you may ask yourself, nasaan na yun? Ano to? Supercritical fluid. So, this is the what we call point when you cannot distinguish if it's a gas or what we call a liquid. Even if you apply more temperature or increase temperature or increase pressure, you cannot change them. Usually, if you add pressure, you can liquefy your gas. But here, even if you add the pressure, your gas will not form into liquid. Okay? Now, the supercritical fluid is really important. Are you familiar with dry cleaning? Bakit
Yeah.
tawag natin siyang dry cleaning? Bakit dry cleaning ang tawag natin?
Gumagamit ng tubig.
Walang tubig. Pero paano siya nagki-clean?
May nilalagay po na substance po ata dun sa something.
Ano yun? You know, this is testing me if you're watching my video. Because I put some specific example on that. So they have this perchloroethylene. So siya yung nagdi-dissolve doon sa dirt. Now, the form na dinidissolve niya yung dirt na yan is in the supercritical fluid. Another example or application of this one is when you want to remove caffeine from your coffee para meron kang decaf. Before they would use organic solvents, but you don't want to drink anything na may trace ng chloroform, dichloromethane. So what you do is you do supercritical fluid like CO2. Okay? So it is a very useful process. There's a lot of application. Now, another thing that we can look at this, what we call phase diagram is this. So typically, most of the phase diagram are like this one. So the slope is, what is that? What we call this slope? Positive, negative. Itong tinuturo ko. Is this a positive slope or a negative slope?
Positive.
It's a positive. Ano yung definition niya sa slope? Rise over run, di ba? So this is a positive slope and this is a negative slope. So if we're going to look at this, so this is a typical phase diagram. This is a unique phase diagram. Now, anong explanation yan? Bakit may ganyan yung typical? The explanation here, if you have a phase diagram na yung fusion curve niya, positively, yung positive ang slope. Because most of the density of solid is higher than the density of the liquid, but you don't observe it here. Why? Ano ng water? Usually, ice would what? Float in water. So that means the density of the solid in water is less than the density of the ice. The density of the ice is lower than the density of water. Make sense? And in addition to that, you can get information here. What is CO2? Anong other term natin sa CO2? Anyone? Anong tawag natin sa CO2?
Carbon dioxide?
Yeah, but what's the common name for CO2? Are you familiar with dry ice? You're familiar with dry ice?
Yes po.
Yes po.
Yes, sir.
Okay. So why do you call it dry ice? Why do you call it dry ice?
Kasi hindi pa nag-aamon sa liquid.
Okay. Because you don't see the liquid phase. And this phase diagram tells us why. Okay. Why? Atmospheric pressure is 1 atmosphere. And if you could see at 1 atmosphere, there are only 2 phases of dry ice. It can either what? A solid or a gas. So that's the explanation why you don't have a liquid carbon dioxide. Because based on the phase diagram, at 1 atmosphere, it can only exist in 2 forms. If you want it to exist in liquid form, what do you need to do? Either you increase the temperature and at the same time increase the pressure. Para umabot siya doon sa region na yun. Now, what other information we can get? So, at 1 atmosphere here, anong tawag dito sa point na to? Itong tinuturo ko. Anyone? Ano yung point? Pag nilagay ko ng point na yan, ano yan? Solid to liquid. Anong tawag dyan? Ha?
Melting point.
That's the melting point or freezing
Fusion.
point. Okay? Melting point papunta doon, freezing point pagpabalik. Now, how about this? What do you call this? At 1 atmosphere and 373 Kelvin, that is your normal boiling point. Okay? So that's the other information that you can get from the phase diagram. Now, you can look at some of the thing here. So another way that you can ask here, maybe ganitong ganito, tapos tanungin sa inyo, what is 1? What state in 1, state in 2, state in 3, and so on. So ang tanong, kaya nyo na?
Yes po, sir.
Yes.
Practice this one. It is available. And speaking of that, I just want to see, because I'm not happy with the result of your first exam. So I tried to do this survey because I have a notion that you don't study or you don't utilize the material given to you. So answer as honestly as you can. Anyway, I cannot trace kung saan ano yung sagot niyo. So you're 24 or 23, and only half of you are participating. So I'm going to end this one. And this is what the result is. So if you cannot watch the recorded lecture, at least do the first two. The recorded lecture is an additional resources for you. But that cannot be everything. The module is the first and foremost, the one that should help you. And at least isa lang sa inyo hindi nagbabasa ng module. Okay? And then I hope that you know that these resources that I'm using right now, it is available for you. Okay? So I understand you cannot watch the recorded lectures because not all of you has internet access. Because I don't know, if you're going to look at the exam, if you are a typical UP student, that should be very easy. But I was surprised with the score that you have. So imagine if the exam is what? Close notes? And I don't know if you're going to agree with me, but the lab is much worse compared to the lecture exam. Right? Tama ba? Mas mahirap yung lab exam kay yung 18.1 nyo kaysa sa 18 na exam. Tama? Hindi kayo mahiya.
Pareho lang po.
Pareho lang? Abot yung iba. Okay? So question on module 5. So we cover module 5. Tanong? Before we go back to module 4. I know the one that we covered in detail are the IMFA. Hindi ko alam kasi first time ko magturo nitong 18. I usually teach the higher one. They just don't have enough people. So they ask me if I can teach the course. And since I'm teaching the Gen Chem 1 and Gen Chem 2 here, why not? And based on my experience, the lab exam there in UP is always more difficult than the lecture. Okay, so here you can look at the links that you have here. So if there's a question that you have or video, they're shorter than the one that I have, so you can do it. And I like this guy. Don, 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 don. Kasi ginagamit ko rin yan sa klase ko. Okay? It's a short explanation. And then there might be some problem solving here that they have to solve the things, so just follow the thing that you have here. Mostly these are the type of questions that you will be asked. Okay? I'm just a little bit kasi ang taas ng tingin ko sa mga UP student. Pero yung score nyo, para yung mga student ko dito sa US. So, this part, the solid, liquid, and gases, I didn't really go that into detail. But if you're going to look at the resources here, I was hoping that you will see it and read it. Okay? So, what is telling us, yung KMT kasi kinetic molecular theory, that is a model that used to describe the behavior of the gas. Okay? Bakit sa tingin nyo ang tawag sa kanya is kinetic? Because it's always moving. And gas is the only one that is moving. But you can apply in principle yung kinetic molecular theory doon sa liquid tsaka sa solid. Kasi may movement pa rin naman eh. In terms of the liquid, they flow or pass one another. Okay? If you're going to look at the properties that you have there, ang difference ng liquid sa at solid doon sa gas ay the presence of the IMFA. Gas doesn't have an IMFA, intermolecular forces of attraction. Pero yung liquid tsaka solid meron. And that's what holds them together. Okay? So, if you're going to look at the what we call movement here, so liquid, their distance is a little bit far compared to the solid, they're able to have some movement. Kaya nag-a-apply pa rin yung kinetic molecular theory. Even the solid, they have vibrational movement. Let's say ice. Try to imagine my head is the oxygen and my two hands is the hydrogen. They have this movement. We call it stretching. This is symmetrical and this is asymmetrical. And they use that principle to develop an instrument known as IR that determine the functional group. Okay? And then in addition to that, meron kayong tinatawag na classification of solids. So how are you going to what we call classify if you're given a solid? Well, it depends. Okay? So you can classify it in terms of crystalline, where everything is in order, or amorphous, where they're not in order. Or you can classify it based on the type. So what we have here, ionic, metallic, covalent, and covalent network. So you just start from doing this one. So yung name nila is dependent doon kung ano yung attraction nila. So you have 3 intramolecular or the bond. So the ionic solid, they have ionic bond. So they have a cation and an anion. Okay. They won't conduct electricity, but if you dissolve them in liquid, they can conduct electricity. What conduct electricity? Anyone? Ano yung nagkaka-conduct ng electricity? Usually the presence of what? Anyone? It's just the presence of electron. Sa ionic solid, there's ionic bond, so there's no presence of free electron. But once you dissolve them, the electrons are already available, cation and anion. So they can conduct electricity. Now, metallic bonds are usually the metals. Okay. So you just look at the typical properties of metal. Now, covalent, itong dalawang covalent, ano yung pagkakaiba? So when you have covalent network, you have covalent bond as the force that hold them together. But covalent molecular, you have the IMFA. So what's the possible questions that you have here? So if you're going to look at the question that you might have here, maaaring kagaya nito. And I answer already. Describe the main difference of amorphous and crystalline. So this is highly ordered and this is not ordered. And then how do you identify the type of crystalline solids? Fe, ano yan? Class. Ionic, metallic, covalent network, covalent molecular. Hello?
Metal po.
Metallic.
It's metallic. MgO.
Ayun.
Ionic. C12H12O11. Sugar.
Covalent.
Covalent molecular.
It's a covalent molecular. So, ganun yung mga tanong. Kaya nyo?
Yes.
It's chapter 11 on my recorded lecture. You have 4 chapters doon sa recorded lecture ko nung dalawang module. Module 4 is made up of chapter 5, which is gases, and chapter 11, that has the IMFA, and this type of solids. Okay? Saka yung properties of liquids. Module 5 is made up of chapter 6, chapter 19 or 18, and chapter 11, yung phase diagram. Now, ano pa yung ano dito sa IMFA? Properties of liquids. So we only have what? Surface tension and viscosity. Familiar kayo dun sa dahon ng gabi? Class?
Yes po.
So
Yes.
pag nilagay niyo ng tubig, ano nangyari sa tubig?
Nag-roll off.
Nagro-roll siya, no? That is a proof of surface tension. What trying to do is the water molecule try to pull, okay, the water droplets. Kaya pag meron kang wax paper, nilagay mo ng water, may magpo-form na drop. But if you use gasoline, pag nilagay mo, kita mo kalat. Because the IMFA is not strong enough, so the surface tension is not strong enough. Now, sa surface, if you have enough surface area, it can make your substance float. Like for instance, this pen, pag nilagay mo ng ganito, pwedeng mag-float. Pero pag nilagay mo ng ganito, lulusot lang, lulubog. Okay? Yun yung surface tension. And it depended on IMFA. The stronger the IMFA, the higher the surface tension. Now, yun namang isa, viscosity, it is the resistance to flow. Surface tension is also an effect on the capillary action. Okay? Yung viscosity naman, dependent also on IMFA. Ano yung viscous material? Any example of viscous material? Yung
Honey?
Zero.
zero. And you may be asked why? There's a lot of OH bonder making it viscous. So the higher the IMFA, the higher is the viscosity. So the more viscous it is, the slower will it flow. Okay? And then you can go at the different gas law, the kinetic molecular theory, so properties of gas. So usually there's 4 properties of gas: the pressure, force over area, the temperature, okay, the amount of the substance, and what's the other one? PB equals to nRT, volume of the material. And usually we have the different gas laws. Now, ideal gas law is just the summation of the natural, what we call gas law. We have PB equals to nRT. Okay. So when we have the ideal gas law, it is a combination of Boyle's law that looks at pressure versus volume. So there's an indirect relationship. The higher the pressure, the lower the volume. Charles law that looks at the direct relationship between the volume and absolute temperature. The higher the temperature, the higher the volume. Okay. Avogadro's law, which relates between the volume and the amount of the substance. Okay. So their combination gives you the so-called PB equals to nRT. But if you're going to look at the ideal gases, there's a limitation on it. I think if I'm not mistaken, the limitation is it behaves ideally at low pressure and high temperature. But sabi nga nila, not everything is ideal, right? So when we have real gases, they don't obey the ideal gas equation. The ideal gas equation, when they collide with one another, their collision is elastic. But in real gases, when they collide one another, there's a chance that there will be attractive forces, right? Now having an ideal boyfriend, tall, dark, and handsome. That the real boyfriend is what? Tall, dark, and handsome, some sort of that. So there's always a limitation of this ideal gases. So if they don't obey the ideal gas law, PB equals to nRT, they're what we call real gases. Okay. So kinetic molecular theory. So these are the basic statements that you have there. And usually it can explain that thing. So what else? Yep, I think yun lang. I'm thinking if we can have the quiz maybe what? Sunday to Monday? Para makapag-prepare kayo? What do you think? Now's your time.
Monday, sir?
Maybe Sunday to Monday?
Yes, okay lang sa akin, sir.
Yung iba?
Yes, sir.
Okay lang po Sunday.
Okay po, sir.
Because I don't want it to be long. I want to mimic what you called your exam. Di ba yung exam niyo 2-hour window, 2.5 or 3-hour window lang? But you have to take it in 2 hours. So I want you to at least study this weekend. Don't want to say have a great weekend because you should not have a great weekend, especially if your exam is not good, the first one. And I expect you to at least have a better score compared to the first one. because the next one is going to be more difficult. Equilibria, they're abstract concept. So we will go on with equilibrium on Tuesday, and then Thursday maybe last minute review or last minute question that you have. So what do you think? Wala ba yatang sumagot dun sa discussion eh? If I'm not mistaken, pa isang tao lang ata sumagot dun. So you have here, I asked you to answer last time. So only one. Yeah. That's all. Walang ibang sumagot. So I want you to look at the module, the material that is linked there, and then the 4 recorded lecture, the 4 chapters that cover them. And then I gave you in your group chat the review sheets, right? Ilang chapter yung iniwan ko doon? It should be 4 chapters. 5, 6, 11, and 19, if ever. So tanong. May tanong?